So we are going to start with this today. So I'll just give you an overview what this is.
What
Have you done
different?
this?
I mean,
Differentiation?
I've heard of it. I don't actually know what it is. But I'm
Okay.
assuming this is like the first topic that would come up in September.
No, the first topic will be functions, right? Which is very easy. I don't want to do that in a demo session.
Yeah,
So
that's
this is
fine. Okay.
little, yeah, this is a little trickier and interesting also. Easy
Okay.
also if you got the concept. So it's not such difficult thing. Maths is always easy. If you understand the concepts, you can solve any type of question
Yeah,
from any book, right?
that's why I
So
prefer maths to like English and stuff because like once you
you like
understand
English
something,
too? Yeah. You don't like English? You like English?
no.
No. Me too. I don't like it. I like maths. After that, I like science.
I quite like science as well. I like physics.
Physics. I love chemistry actually. Physics is good, but I like chemistry, playing with the elements and doing equations and everything, balancing them. I like those things.
Oh, nice.
Right. Okay, so let's start with the topic. So you heard of it. This is the first and foremost part of calculus, right? Calculus is basically involving all two types, which is differentiation and integration, which are related to each other, like multiplication and division. They are opposite to each other. So differentiation and integration is opposite to each other. We go
All
on
right.
integration later on, but let's concentrate on differentiation today. So you may have done slope or gradient in the previous grade, right?
Yeah.
So can you explain me what does slope or gradient actually means?
The gradient of I will do like a straight line. So the gradient of like a linear graph is
Right,
essentially the steepness of it, or how steep it
correct,
is.
right. And how, if I ask about the mathematical definition of it, can you tell me like how you will find out the gradient of any
You would
straight?
find the gradient of a straight line. So like the change in y divided by the change in x.
Very good, very easy, right? So
Yeah.
that is basically the change in y over change in x gives you
Mhm.
the gradient. Some
Yeah.
books takes delta y over delta x, or you can even write this, right? So your choice. So I'm not taking this right now because I'm going to use that symbol for differentiation. Okay, change in y over change in x is your gradient or slope. And if I ask you to find it out, you take any 2 points which lie on your line and you subtract the y points and you will subtract the x points and divide them, you will get the gradient. This is for straight line and we easily get these. We can read on the graph, we can find it even if my points are from any real number system value, correct? You can
Yeah.
find on a straight line, specifically on a straight line. But if I ask you, okay, let's find out the gradient of some curves. And there are so many curves whose graphs we are going to study in this level. There is a quadratic, which is the simplest one. If I ask you to find the gradient for this, any idea what you're going to do?
Well, I mean, you can find the curve, like you can find the gradient at a point. If you draw a tangent to the curve, then you can find it
Okay.
then.
Yes, okay. If you draw a tangent to the graph, for example, this is my curve. This is a very standard form of quadratic curve, which is y equals to x squared. And you said, let's draw a tangent to it. So I'm drawing a tangent at a very first point on my first quadrant, which is 1, 1. So now you
Okay.
draw a tangent to it. I
And
have
then you
drawn
find
you a
the gradient like
tangent.
you would normally.
So find the gradient.
So you've done P11. I'm assuming, do I have like another set of coordinates to go with it, or is it just
You can assume this is the graph. This is the curve which I got. And this is the point where I have drawn a tangent to it. So how you are going to proceed with the gradient?
for the gradient of, so we've drawn our tangent now. I'm going to assume
Mhm.
the x-intercept of the graph would be,
Okay.
I'm assuming, x-intercept would
Okay.
be something like whatever,
Okay.
like
Okay. I got your
170.
concept. I got your idea. So that is little lengthy and little like tedious process. Am I right?
Yeah,
We
I'd
know
say
the
so.
process that goes. Yeah, we can say that. So let's try to make it very simple. So you said, let's draw a tangent to it, which is right. But how we reached there? If I have a curve and I take 2 points on my curve which are instantaneously very close to each other. So close that you cannot even find out that they are lying on a curve. It assumes to be a straight line.
Oh,
Okay.
okay.
So that means the change in my x and change in my y is teeny tiny. Very teeny tiny that change approaches to 0. Okay. We are gonna
You're
find out the
changing X with
formula
the
for
symbol.
this. Yeah. So
Okay,
we
so
are gonna find out the formula for this now. Yeah, you're saying something?
yeah, so you're saying that so normally that's okay, but when we want to find the gradient to a curve, like
Hmm.
when you say are you saying like the entire curve gradient, or are you saying
No, no,
like
no,
just
no, no, no. I'm just taking a small portion of a curve because if I find the gradient at any portion of my curve, that gradient will be the same at every portion of the curve. Like for this line, this is how it works. It doesn't matter if I'm using these 2 points and I find a gradient. Will it differ from these 2 points?
no?
No, right? So you can choose any 2 points on the curve which are very, very close to each other, that their change in any of the x's is 0,
Okay,
right? We
changing
assume this. Change.
changing X
Change
is
means
zero,
change in the axis. That means rise over run is
yeah,
almost 0.
almost zero. Fine. Okay,
Okay, that means these 2 points are overlapping with each other, but in this graph, it seems they are a little bit having a gap in them so that I can show you like they are on a straight line. See, if I joined them, I mostly got my straight line.
okay,
And we know that these 2 points lying on a curve, but we are assuming they are very close to each other. So if I found a gradient for these 2 points, that will be a gradient for my curve. But now the question is how? So let's try to develop a formula for this. So
okay.
if my A point, you know that this is the curve of y equals to x square. So if I taking my point A, will I write x square? Is it right? Any doubt over here? I just substituted the value in the function. So my A point will come like this. Is it
So
okay?
the coordinates of your point A
Yes. Yeah.
in
Because
X
yes,
in like
coordinates
X
of
squared.
A. Right.
Surely does it not have like an integer value? This
No, I'm not putting any integer value to it. I am just deriving a formula right now. Because once you got
okay,
it,
so
how
you're
we
saying for
got to
every
the formula.
X. So you're saying every X movement along, you're moving up squared. Fine.
Yes, yes, because
Okay.
that's
Okay.
what my function is. That's what my function is, right?
Okay.
Because
Fine.
I took the quadratic function, right? So this is
Okay.
my A, but B is little far from that. So I assumed there is a little change in X. So there must be a little change in
As well.
my Y square also. So can you apply the formula over here and let me know what you got? Let's apply this
So
gradient formula, change in y over change in x, open the squares. Let's see
that
what it
means
is.
you have what? So should I do it like online or should I do it in like my note?
Your choice. If you want to go on a screen, it's okay. That will be more better. Then I don't have to write it down.
Okay, fine. Let me just get out my pen tab real quick.
Yeah, sure.
It's fine now. Give me one more.
Yeah, sure. Connected.
Yeah, done.
Okay. So you have two coordinates,
Yeah,
2
fine.
points.